Alrighty, Elizabeth, still here in the barn. Hey, look it, I just found some money in my jacket. $6, woohoo! Good thing it was a cold day today. Okay, so we're in the barn. This time I'm looking at your maximize the area problem. Again, I'm not doing the exact problem that you were given because I want you to work on it yourself. Okay, but I'm giving you one similar. So let's say in this case that you had a question that said you have 36 feet of fence to make a rectangular garden. Okay, so you want a little rectangle that's fenced in so the dogs can't get in, whatever. You need to maximize the area though. You want to have the biggest garden that's possible. So these types of problems are called optimization. Okay, so these are the optimization problems. And I've written you kind of a little list here. No matter what the optimization problem is, this is kind of your go-to. First thing is that there's almost always going to be two equations. So the idea is if the two equations are given to you, fantastic. If they're not, like in this case, we have to write them ourselves. Then the second thing is that we're going to take those two equations and we're going to substitute one into the other to get one equation, because essentially we just want one equation. Once we get our one equation, we're going to find the derivative and then find the critical value, because that critical value will be either a max or a min. Okay? So the hardest part here is this first part, because you already know how to find the derivative. So this should be the easy part now. This is the kind of crappy part. Okay, so when we look at this problem, we're talking about a shape. We're talking about a rectangle, and you're going to fence it in, which means that we are talking about perimeter, aren't we? The other thing it's asking us about is area. So our two equations that we are going to have are going to be perimeter and area. So remember, we're looking at a rectangle here, so perimeter would be 2L plus 2W. And area will be L times W, right? Length times width. There are our two formulas or equations. Now we can get a little bit more precise on one of these because we actually know what our perimeter will be in the end. We have 36 feet of fence, we want to use it all. So we can actually eliminate the P there and say that we know that this should equal 36. So there are two equations. Now this says that we want to maximize the area, which means this is the function that we are really interested in. We're going to use this one, but this is the guy we really want. The problem is that it has both an L and a W in it. We don't want two variables. We just want one variable, and that's where this substitution is going to come into play. So it does not matter which variable you solve for, absolutely doesn't matter. My last name is Woods, so let's get the W alone just for the heck of it. So in this top one, we're going to subtract the 2L from both sides. So we'll end up with 36 minus 2L equals 2W. And then we will divide by 2. So we get W equals 18 minus L. Now, that means that we can take this W equals 18 minus L and we can stick it right there. So we're going to say A equals L times 18 minus L. Now, if we're going to have to do any work on this, don't leave it like that. Multiply it out. So A equals 18L minus L squared. So we use the perimeter equation and we substituted it into the area equation, and now we just have L's instead of L's and W's. So we've done that. Area is the function that we're interested in because we want to maximize the area. So we've got the equation we want. Now we find the derivative. So we'll say A prime equals 18 minus 2L. And then we will set it equal to 0 to find the critical value. 18 minus 2L equals 0. So 18 equals 2L So L will equal 9, right? Okay, L equals 9. Hello, my brain's not working. As always, it's too cold in the barn to be doing this, but this is my classroom. This is where I've been teaching class for the last 4 months. Okay, so L equals 9, and what were we in? We were in feet. Okay, now, make sure that you answer the problem fully. If it asks for all your dimensions, we're not done. We've only found the length. If we need to find the width, then we need to come back up here and say W equals 18 minus L, or 18 minus 9, which is also 9 feet. But be sure with these optimization problems that you actually answer the question. Another question that they might throw in there is, what is the optimal or the max area? So find max area. So what if they don't want the dimensions, they want the actual area? Well, can you go 9 times 9 and say that that's 81 square feet? So there's lots of different little questions that they can ask you here. So make sure you read the question when you're done. Don't be like, woohoo, I solved it, and move on. Okay? Think about it for a second. Alrighty, so again, 2 equations. Substitute one into the other, derivative, critical value, and then answer the question. Now, the other thing, just as a little hint, if you're ever making a rectangle and you need to maximize area, so 4-sided shape, maximizing the area means to turn it into a square. The square is the most optimal rectangle there is. So when I saw this problem, I didn't have to do any of this work because I know when it says maximize the area of a rectangle, I want to turn that rectangle into a square. So I just did 36 divided by 4, so each side was going to be 9. Okay, now that only works when you're doing a rectangle. If they give you some other shape, a 3-sided shape or something like that, it doesn't work. But if you ever need to maximize a rectangle, it's always a square. Okie dokie. Okay, so you had one other question that was about the Pythagorean Theorem, if I am correct. Actually, why don't I just push stop here and I'll go look at that problem and then we'll do another little video. Okay, back in a minute.